This lesson is on solving linear systems of equations using elimination. We are going to have two different ways to be doing this depending on how the system is given to us. So we have, like we know a system is, two linear equations. They're going to be put on a graph and we're going to see where they want to intersect. Let's first start with the summary, and there are 5 steps to solving linear systems by elimination. The first is to write the equations in standard form. So ax plus by equals c. Okay. The second step is to multiply one or both, depending on what we need, equations by a number so that a variable will be eliminated. The next step, 3, we're going to add the columns, which are the like terms. The fourth step is going to be to solve for one of the variables. And the last step is to substitute from step 4 to solve for the remaining variable. Okay? So this will all make a whole lot more sense as we're going through it. So the first was standard form. Both of my equations are in standard form. Then I'm going to look to see if there is a variable that I can cancel out by adding or subtracting. And there is. These x's are the same with different signs. So if I add them together, 5x, negative 5x plus x, it zeroes out, which is what I'm looking to, eliminate one of the variables. Then I'm going to continue on. I didn't need to get a variable to be eliminated because one already did automatically. Then I added the column. The first column, let's add the second column, negative 6 plus 2y is negative 4y, and it equals 8 and 4 is 12. Well, to solve for y then, 0 just cancels out. I don't need to even write that. I'm going to divide by negative 4. Y equals negative 3. There's one of my values. Now step 5 says to substitute this back into either equation. I'm going to put it into the bottom one because there's no negatives. That just makes my life easier. This says that y is negative 3, so it's going in the place of y. Just substituting it into that second equation. It works in either equation though. So 5x minus 6 is 4. Add 6 to both sides. 5x equals 10. And divide by 5, x equals 2. So my solution to this system is 2, negative 3. Example 2. I have to look to see if any of my variables will cancel. Yes, this negative 4 and 4 will cancel if I add them. So 6 minus 3x is 3x. This cancels. 3x equals, add these together, 15. Divide by 3, x is 5. I can plug it back into either equation. It does not matter which one. I'm going to plug it into the top one. 6x minus 4y is 14. So 6 times 5 minus 4y is 14. I plugged it in for x because it said that this is what x was. 30 minus 4y is 14. Subtract 30 from both sides. Negative 4y equals negative 16. Divide by negative 4, y is positive 4. So 5, 4 is my solution. Example 3, I have 3y and 3y, but they're both positive. So if I added them, it would give me 6y, and it would not cancel it. So I am going to subtract this whole bottom equation. And to subtract, you could just keep change. So keeping the top the same signs, changing this to a positive, and then changing all of the signs in the bottom equation. So 4 plus negative 5, or 4 minus 5, is negative 1x, or negative x. 3 plus negative 3 does cancel out, so negative x equals 2 plus positive 2 is 4. Divide by negative 1, x is negative 4. Let's plug it back into the top equation. 4, not times x, I'm substituting in negative 4 plus 3y equals 2, and solve for y. Negative 16 plus 3y is 2. I'm going to add 16 to get rid of it. 3y equals 18. Divide both sides by 3. Y is 6. So negative 4, 6 is my solution. Example 4. I'm going to also have to subtract here, or just change the signs of everything. So I have 6x, I'm adding columns. This cancels, equals 24. Divide both sides by 6, x is 4. Plug it back in, let's plug it into the top one. 5 times 4 plus 6y is 50. 20 plus 6y is 50. Subtract 20. 6y is 30. So y is 5. 4, 5 is the solution. So that's nice and easy when I have the same coefficient for one of those variables, even if I do have to change the sign. But now we're going to look where we have to incorporate that step 2, multiplying, to get one of the numbers the same. Okay? So in this example 5, none of my coefficients are the same. They are in standard form, so that's nice, but I'm going to want to cancel out the variables. I could make this x into a 3, or this y into a 2. It doesn't matter. I'm going to say, let's change this bottom equation, and we'll make the y's cancel. So to make the y's cancel, I need to multiply this equation by 2. So then I have to distribute negative 2x plus 2y equals 2. Now this equation is done. I just distributed to make my coefficients, the same. And I'm going to rewrite this down here. I'm going to write 3x minus 2y equals 3. Just so that they're lined up and I can add nicely. And 2 plus negative 2 does cancel, so I know I'm going to add. They're opposite signs, so add. So I have x equals 5. That was easy. Now I'm going to take this equation, this x, and plug it into the top equation. So I'm going to plug it in to 3x minus 2y is 3. So 3 times 5 minus 2y is 3, and solve for y. 15 minus 2y is 3. Subtract 15 from both sides. So we're equal to negative 12. 3 minus 15 is negative 12. And divide by 2, y is 6. So 5, 6 is your solution. We got 2 more to do. Now, I cannot make a 2 into a 3 or a 3 into a 2. So that's not going to be my first choice to cancel out x. I can see that this 5 can become a 10 if I multiply it by a 2. But I really want my signs to be opposite. So I'm going to multiply it by a negative 2 to give me a negative 10y. And don't forget to distribute to the other part. So negative 4x, that minus 10y, negative 2 times 3 is negative 6. And now this top equation's done. Let's just focus on this bottom part. Opposite signs, so I'm going to add. I'm left with negative x equals negative 9. Divide both sides by negative 1. X is positive 9. And let's plug it in. We can plug it into either equation, either original equation. Let's plug it into the second one. 3 times 9 plus 10y is negative 3. So I have 27 plus 10y is negative 3. Subtract 27. 10y is negative 30. Y is negative 3. 9, negative 3 is my solution. And the last one, I can't make a 4 into a 3 or a 3 into a 4 or a 5 into a 2 or a 2 into a 5. I'm going to have to multiply both equations. Okay? Since this is already opposite signs, I'm going to make the x's cancel. I'm going to multiply the top one by 3 and the bottom one by 4 to give me a common 12x and then plus 15y will equal 3 times 35 is 105, and then distribute the bottom. Negative 12x plus 8y equals negative 36. So those equations are done now. All I have is this. X's are opposite signs, so let's add them. They cancel. 15 and 8 is 23y, and 105 plus a negative 36 is 69. Divide by 23, y is 3. And substitute it back in to either equation. I'm going to put it into the top one since there's no negative. So 4x plus 5 times 3 is 35. So 15 is what that reduces to. And subtract. 4x equals 35 minus 15 is 20. Divide both sides by 4. X is 5. My solution is 5, 3.